Hello, my dear children. Welcome back to our class. Today, we are going to take a new chapter, Chapter 14, Chemical Effects of Electric Current. Chemical Effects of Electric Current. In this part, we are going to learn the chemical effects. Okay. Children, normally, your elders might have cautioned you against touching an electric appliance with wet hands. Most of you have experienced that. But do you know why it is dangerous to touch an electrical appliance with wet hands? In our earlier classes, we learned that the materials which allow electric current to pass through them are good conductors of electricity. On the other hand, materials which do not allow electric current to pass through them are poor conductors of electricity. When you are in 6th standard, we made a tester to test whether a particular materials allow the electric current to pass through it or not. We also learned the use of a tester. We know that some metals such as copper and aluminium conduct electricity. They are known as conductors, the material which allow electric current to pass through them. At the same time, we learned about materials such as rubber, plastic, wood, etc., which do not conduct electricity. They are known as insulators. Insulators are the materials which do not allow electric current to pass through them. Do you remember that? So, we have used tester to test materials which were in solid state. Right? But what about liquids? Do liquid also conduct electricity? Let us learn that. Now you can see a picture showing a battery is connected to a tester and the bulb glows. You can see the ends of the tester is made up of metal, so it carries current and the bulb glows. And here you can see another picture showing lemon juice is added in water, that means in the solution, and the circuit is connected. When the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. We know here in the first activity, as we discussed, metals conduct electricity, whereas here in this liquid, you can see lemon juice. It contains acid in it, so it conducts electricity. Children, remember, pure water or distilled water do not conduct electricity. But normally rainwater, rainwater contains more amount of salt in it, so it passes current. We learned that water conducts electricity. At the same time, pure water or distilled water do not conduct electricity. Here, when you add a drop of acid in the liquid, it starts to conduct electricity. In acid, as we learned earlier, it contains hydrogen ion concentration more. So here when you add lemon juice, it contains acid in it, so it is able to pass current through it. In some situations, even though the liquid is conducting, the bulb may not glow. We already learned the reasons. Do you remember why the bulb glows when the electric current passes through it? Due to the heating effect of current, the filament of the bulb gets heated to a high temperature and it starts glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. Why is the current in the circuit weak? Though a material may conduct electricity, it may not conduct it easily as a metal. As a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb glow. Now you can see a picture here showing another tester which can detect a weak current. Here we can use another effect of an electric current by using another kind of tester. Here we use a compass needle. Do you recall that electric current produces a magnetic field? What happens to this compass needle kept nearby when current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Right, children? All of you are familiar with this, right? LED. The full form of LED is light emitting diode. Light emitting diode. Now you can see there are two wires called LEDs which is attached to an LED. One LED is slightly longer than the other. You can see that in the picture. One LED is slightly longer than the other. So when we connect, while connecting to a circuit, the longer LED is always connected to the positive terminal of the battery and the shorter LED is connected to the negative terminal of the battery. So here you can see the use of an LED. Normally instead of electric bulb which we use for tester or testing the conductivity, we can use LED also, and the way we have to connect. That also I told you, when we connect it to a circuit, the longer LED is connected to the positive terminal and the shorter LED is connected to the negative terminal of the battery. Okay, in the beginning we already discussed that some liquids are good conductors of electricity whereas some are poor conductors. Most of the materials can conduct electricity. Okay, so they are known as good conductors, and those who do not conduct electricity are known as poor conductors. Here we know water. Pure water or distilled water do not conduct electricity. See children, when salt is dissolved in distilled water, salt means it's not only the common salt which we use at home, generally the products we know what are salts. So when salt is dissolved in distilled water, we obtain a salt solution. This is a good conductor of electricity. The water that we get from sources such as taps, hand pumps, wells and ponds is not pure. It may contain several salts dissolved in it. Small amount of mineral salts are naturally present in it. This water we can say a good conductor of electricity. On the other hand, distilled water is free of salts and it's a poor conductor. Okay, when common salt, that also we discuss common salt, dissolved in water or in distilled water, it becomes a good conductor of electricity. Okay, so rainwater conducts electricity. I think now you got the answer for that. Pure water or distilled water doesn't conduct electricity. Okay. Children, remember, most liquids that conduct electricity are solutions of acid, bases and salts. Most liquids that conduct electricity are solutions of acid, bases and salts.